For today's lesson, you will be simplifying expressions with like terms. And as a reminder, if you have n plus n plus n, these are all like terms because they have the same variable. There's also an imaginary 1 in front of any variable like that. So you have 3 n's, so you get 3n. Okay. How about if we have a plus b plus a? We have two like terms, so we have 2a plus our 1b. Okay. How about x squared plus x cubed plus x to the 5th? What do we get there for that expression? What are our like terms? Well, there are no like terms because x squared is a separate term from x cubed and x fifth. So our answer is simplified just like that. Now if we had x squared plus 2x squared plus another x squared, we are going to add all of those. Remember the imaginary 1 in front of those variables that don't have a coefficient. Okay, but this x squared is our like term. So we're going to add the coefficients. We get 1 plus 2 is 3, plus 1 is 4 to get 4x squared. We have simplified to get 4x squared. One more thing before we get into today's lesson is that I wanted to go over the distributive property. So we have a times the quantity of b plus c. So remember, when you use the distributive property, you are going to times a times the first term, and then next you're going to times a times the second term. Okay, so let's do this together, I guess, if you will. A times b is ab plus, just bring that plus sign down, and then a times c is ac. Okay, that's using the distributive property. You're going to be using that in this lesson for 1 or 2 problems. So let's go ahead and look at number 1 in lesson 6.5. So we have 2/5 x minus 8/5 x. Again, we can look at this problem and recognize that we have two like terms. So we're able to subtract these two together. We also notice that we have two same, or a common denominator of 5. And before we get into this problem, I want to go over a concept again, the distributive property, and how we can undo this problem using the distributive property. So if you notice, you have a like term of an x. So it's in this term and it's in this term. So I can pull it out. And then what I can do is I can take this coefficient in front of this x and write 2/5 minus, using that subtraction sign, and then 8/5. So what I did was I kind of undid the problem. This is the same as this. But if you notice here, if I were to use the distributive property and I were to times x times 2/5, x times 2/5 is 2/5 x minus x times 8/5 is 8/5 x. And if you notice, these are the same exact expression. So this is, I just showed you that we undid it in order to get the same thing. Now I haven't even started the problem yet. Hopefully you understand what I did, but I did want to show you here this distributive property concept of being able to pull out this x here because it's common, so that you could better see just the math problem that you need to solve. Okay, so I'm going to go ahead and write this over again right here. Just so I can better see my problem. Once I pull this x out, I can basically work out the math and then go ahead and bring my x back. Okay, so we have a common denominator of 5, so that stays the same. And 2 minus 8 is a -6. Okay, and then don't forget to bring down my x, and that's my answer. Okay, For those of you who want to go one step further, I guess, and make your division problem a little more easy for the eye to look at, you can move both your common denominators to a 5, and then that might help you to see that it's a -6. I don't know, but some might like it like this, some might want to change it to this, and again, if you do that, don't forget your x. For number 3, you will notice that you have 2 like terms with your x, but you'll also notice they have 2 different denominators. So what you need to do again is pull out that common term of your x, and then you're going to fill in the coefficient on that x. So 7/5 minus 2/3. So I kind of unraveled this problem. I undid this problem. Now if I were to go, I'm just going to put the distributive property concept in so you can see it. If I were to multiply x times 7/5, I would get 7/5 x, and then x times 2/3, I would get 2/3 x. Okay, and then that subtraction sign is just my operation. So what I see here though is that I do not have a common denominator, and I need a common denominator before I can subtract these. So what I'm going to do is I'm going to find a greatest common a greatest common factor, which would be here would be a greatest common multiple. So if I'm going to list the multiples of 3 and 5, I would start by just saying 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on. And then 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. Well, I might as well add 15 because that's going to be my my greatest common multiple. So I have found my greatest common multiple for these 2 numbers. Another way you can find a greatest common denominator, a common denominator, is to just simply multiply these 2 together. So if you notice, I did list the multiples of 3, and I listed the multiples of 5 to find the lowest common multiple. However, sometimes you can just multiply these, and in this case, it comes out to the same answer. So let's go ahead and turn our denominators into 15. And how I do that is I just simply multiply my 5 times 3 to give me 15. And what I do to my denominator, I have to do to my numerator. Remember, I can do that because 3 divided by 3 is 1. So if I multiply 7/5 times 1, I'm not changing this at all. That's how I can do that. And then I'm going to multiply 3 times 5 to give me my denominator 15. But what I do to the denominator, I need to do to the numerator, because again, 5 divided by 5 is 1. And I'm not changing 2/3 because 2/3 times 1 is 2/3. So let's go ahead and evaluate this what's in the parentheses here. 7 times 3 is 21, minus 2 times 5 is 10, and now I have a common denominator of 15. Okay, and I'm going to bring down my x. Don't forget about that. That's important. 21 minus 10 is 11. And then my denominator of 15, and then bring down my x. My answer is actually x times 11/15, which is 11/15 x. We can't necessarily leave it like this because this isn't proper. This is in proper form. For number 5, we can see that we have a common term, a like term of x. So let's pull that x out. And then we have as our coefficient -5 plus 7/2. Okay, so I kind of just undid this problem, pulling out my like term right there. And now we need a common denominator of a 2. So I have nothing here, so basically I could just make it a 2, but I do need to put a 2 in the numerator spot. Again, I can do that because 2 divided by 2 is 1, so I'm not changing this -5 at all. So go ahead and rewrite my problem again. Negative 5 plus, or sorry, negative 5 times 2 is a negative 10 over 2 plus 7/2. And I'm going to rewrite my problem again just so it's easier on the eye. Negative 10 plus 7, and there's my common denominator of 2. And then negative 10 plus 7 is a negative 3. Again, remember, the bigger number with that negative, that's the sign you keep. Okay? And then 2. And then I'm going to go ahead and write this properly as 3 halves x. Negative 3 halves x. Okay, looking at number 7, I see that I have a common or like term of z. Now, for those of you who have been in my class, you know that these z's, I draw these lines through them because I don't want to confuse anyone. Sometimes our z's can look like a 2. So when you see me write those, there's z's, and just so we don't get them confused with 2's. So anyway, our like term is a z. So I'm going to pull that out, and I'm going to write the coefficients or the numbers in my parentheses. Okay, I notice that I need a common denominator of 3. So I'm going to write my common denominator of 3, and I'm also going to put it in the numerator spot. Again, 3 divided by 3 is 1, so I'm not changing my 9. 9 times 3 is 27 minus 4 divided by my common denominator of 3. 27 minus 4 is 23. And to write this in proper form, 23/3 z. For number 9, we have 1/2 x plus 1/3 x plus 1/6 x. We recognize that our x's are our like terms, so we're going to pull them out. We're going to list our coefficients of those terms. So 1/2 plus 1/3 plus 1/6. Again, I can do this because if I were to multiply x times 1/2, I'd get 1/2 x. If I were to multiply x times 1/3, I'd get 1/3 x, and so on. So I need a common denominator here, and I recognize that 6 is my largest number, and 3 goes into 6, and 2 goes into 6. So I need to change my denominators to 6. So 3 times 2 is 6, and I do that to the numerator spot as well. 2 times 3 is 6, and I do it to the numerator spot as well. So I'm just going to go ahead and multiply 1 times 3 is 3, plus 1 times 2 is 2, plus 1, all divided by my common denominator of 6. Now 3 plus 2 is 5, plus 1 is 6, divided by 6. And we know that 6 divided by 6 is 1. I'm just going to go ahead and write that for sake of being thorough. And then 1 times x is 1x, or x. For number 13, we have a problem here that's a little bit more lengthy and seemingly complex, but if we keep it nice and organized and in order, we should have no problem. So I can recognize, or I recognize that I have this y term, and then I have this y term, and then I'll just mark it in blue, but I have this w term and this w term. These are like terms, the two w terms, and then these y terms are like terms. So I'm going to group my y's together, and I'm going to group my w's together. So let's start with the w's, because when you're listing an expression or listing like terms, you'll always want to go in chronological or alphabetical order, and w comes before y, so we'll list the w's first. So we have a positive 2/3 W minus, the sign is in front is very important. You want to take the sign with the term. So minus 4/3 W, okay? And then we have a positive 7/9 Y, so I'm going to add 7/9 Y, and then I have a negative 5/9 Y, so obviously 5 negative or minus 5/9 Y. Now, couple of things you could do here. You could just simply recognize that 2 minus 4 is 2, so you get 2/3 W, and you can recognize that 7 minus 5 is 2, so you get 2/9 Y, and that would be your answer. But for sake of being thorough, I'm just going to undo these problems, okay? So I'm just gonna like break it in half, if you will. So I recognize that I can pull out my W's here and write 2/3 minus 4/3. And over here, same thing, pull out the Y because those are common or they're like terms, and write the coefficient out, 7/9 minus 5/9. Okay, and then so I'm going to simplify this. 2 minus 4 is a negative 2 over 3, and then over here I have, and again there's a positive sign here, so it's plus plus. 7 minus 5 is 2 over 9. And so essentially I have my answer, but I need to write it in proper form. So we have a negative 2/3 W plus 2/9 Y. A positive, negative 2/3 W plus 2/9 Y. For number 22, we have 8/7 x squared minus 6x plus x squared minus 7x. I went ahead and underlined the like terms, and then we also have these like terms right here. Okay, we're going to group our like terms together. So again, we want to go in chronological order, so we'd start with the x first and then the x squared. So we have negative 6x minus 7x, and then we also have a positive 8/7 x squared plus x squared. So I'm just going to go ahead and basically add left to right. Negative 6x minus 7x is a negative 13x. Everyone see that? So we have two like terms. We have two negative numbers. 6 plus 7 is 13, but we have two negatives and we're adding negatives. So negative 13x plus we have 8/7 x squared plus 1 more x squared. So basically you can just say 1 and 8/7 x squared, because we're just adding 1 plus 8/7. So we can do it like that. 1 and 8/7 x squared. Now it's not really in proper form to have this improper fraction here, or I'm sorry, a mixed number like this, because the 8 is larger than the 7. So I would go ahead and turn this into an improper fraction. So negative 13x plus 1 times 7 is 7 plus 8 is 15. Denominator stays the same, and that is your answer. Number 24, we have a couple like terms here, 7b and 4b, and then we have negative 2/5 c and negative 7/10 c. So let's group our like terms together. We have 7b plus 4b, and then we have a negative or minus 2/5 c minus 7/10 c. Now our 7b plus 4b, we can just easily say 11b, because 7 plus 4 is 11. They're like terms, so when we add like terms, we're just going to add the coefficients and put that b just like that. And then now we have a little special situation here where we need to have a common denominator. And I will choose 10 because 5 times 2, I'm just going to write it in here, is 10. So what I do to the bottom, I do to the top, numerator or denominator and numerator. And now I have 4 on top and 10 on the bottom. So I'm going to go ahead and leave my 11b alone and just deal with my common terms here. If I were to group these together, I have a negative 4 minus 7 over 10. And I'm just going to put it like this. So if I do that, I'm going to add whatever I get here. So negative 4 minus 7 is 11, or I'm sorry, negative 11 times c plus 11b. So this is not written in proper form, so I need to write it over again. 11b plus negative 11 tenths c. Just like that. Now I did assign number 29 as extra credit, but I thought I'd get you started on this one and then we'll see if you guys can finish it, okay? So for this one, I want you to remember to incorporate the distributive property. That's a little hint. There's another little hint, okay? And I'll get you started on this as well. So 6 times 1/5 r squared. If you multiply the 6 times 1 in the numerator spot, you're going to get 6/5 r squared. When we multiply 6 times 5r, you're going to get 30r. And then bring down that negative sign there. 6 times negative 7/3 is going to be a negative 6 times 7. Those are in the numerator spots, because remember 6 is like 6 over 1. So 6 times 7 is 42 over 3, plus 3 times r squared is 3r squared, minus 3 times 5/3, 3 and 5 are in the numerator spot, so 3 times 5 is 15 over 3. So I'm going to leave you at that. I feel like I want to give you more, but let's just see who can try to solve this one. And I hope you guys have a good class, and take care, and God bless you all. Bye.